Okay, hi everyone. This is homework number 2, problem number 30. I went and I did the problem and then I messed up on negative, so I have to, instead of doing the whole video over again, I'm just going to just walk you through it with a highlighter. So a couple things we want to pay attention to is they gave us a graph and it says the light shines from the top of the pole. So the pole is over here, right? And it's making a light shining and it's going to hit a ball. That's the ball as it drops. And when the ball drops, it's going to cast a shadow. See, here's a shadow. And as the ball drops, the shadow starts moving this way. Okay? So as you can tell, the shadow is going to get shorter, and the variable W is what I call the shadow length. See, this right here is W. And as the ball falls down, the shadow is going to move this way. So is the shadow getting bigger or smaller? I'll say smaller. So that's going to be a negative dw dt, just for the future. See, we're looking for dw at t is 1/2. And that's where, how fast is the ball moving along the ground half a second later. Assume the distance the ball falls at a distance of s equals to 16t squared plus in t seconds. Okay, so a couple things we'll start working on. We're trying to figure out how fast the ball is falling. How fast is how fast is the ball's shadow moving along the ground? So I call it W down here. If you look down here, I call it W. Distance of the shadow equals to W. And we're looking for dW dt, for how fast is it changing at half a second later. Okay, so I decided to figure out half a second later, how far did this ball fall? And they give us a formula right here. S is equal to 16t squared. So I went ahead right here, said S equals to 16t squared, where t is our time, and our time is half a second later. Half a second later. So I plug our half a second later in, right here. And 1/2 squared is 1/4. 1/4 times 16 cancels out to become 4 feet. So the ball fell 4 feet. And that's why I ended up drawing on this graph over here. On the graph, I said the ball dropped 4 feet. After half a second, the ball dropped 4 feet. Well, then how high is the ball from the floor? Well, we said the lamp and the ball started off at the same height. And we said that was 50 feet here. If it's 50 feet, that means it's 50 minus 4, which should be 48. So we know that's going to be 48 eventually. 46 feet. 46 feet. But since it's changing, since S is getting bigger, so I call the distance from the top of the ball to where the ball has fallen, the top of the ball to where the ball has fallen, I use that as the variable S. That is S. So 50, whole thing is 50, minus the 5 gives me where that ball is now, and I called that H. See, I called that H. Okay. So a couple things we wanted to see. I drew a very simple model here to help us out. If you look down here, that's with our basic triangles with our big triangle. Right here, this is our big triangle. Okay, you all see that? And my little triangle is the guy on the inside right here. That's my little triangle. And we're going to compare them with ratios. So right here we're going to set up as the little triangle is related to the big triangle side. So W over 3 plus W. And that's related to the other side, which is our short and our long. So that's why I wrote S minus 50 minus S divided by 50. Okay, we know if we take the derivative of W, we need dW dt, and that's what we're solving for. And when I was trying to read through the paragraph up here, there are no other rates. There are no other rates. You can look at it and you'll see there are no other rates. So I decided to just go ahead and use the ratio, which was using the variable s. So I went ahead and what do you think happened here? Do you want the fractions? I didn't, so I cross multiplied. I cross multiplied those across. And you'll see W and 50 get multiplied together, and 30 plus W multiplies with 50 minus S. So we're now here, 50W and 30 plus W times 50 minus S. And in order to get to dW, we're going to have to take the derivative. So I go ahead and take that derivative. In this case here on the right side, since we're multiplying, we have to use a product rule. Product rule. Product rule. Derivative of the front, leave the back alone. Derivative of the front. The derivative of 30 plus W is, the 30 is a constant, so just dW dt, and then leave the back alone. On the back side, take the derivative of the back, and then leave the front alone. Derivative of the back is derivative of 50 minus S, which is just, derivative of 50 is 0, and derivative of negative S is our ds dt. And then leave the front alone there. Our next line, I'm simplifying as much as I can. So on the right side here, I went and I distributed. We end up with this value here. ds times 30. ds dt times 30. And then ds dt times w. Be careful, that's a negative. So we end up with two negatives and a bunch of dS's there. Then I decide to move my dw's to the same side, and we do that by subtraction. We subtract it over going left. You can see that arrow here. We moved it over. We have these two values on my left side now, written here, expanded, and we realize we want to solve for dw, 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 dw. So we factored it out. On the right side, we also, take a step back, we also have two dS's, right? So we factor those out right here. We factor them right here. See, I remember factor there. So we end up with ds on the outside. Now, I'm going to simplify my left side. After I factored out this section, we realize we have a negative times 50 and a negative times s, and that cleans up a little nicely. And we end up with having the 50 and the 50 canceling out, leaving me just the s. Just the s. Now that we're at this stage here, right here, we can start plugging in values that we know for sure. First, we solve for the letter s, and that s value was 4. And where was that located? Remember, we started way up here at the top here. That was 4. S was 4. We plug that in. I'm looking at the next value, w. Now, we don't have a w anywhere. Look, if you look up here, there's no w. So I went ahead and drew my ratios right here. Take a look here. Since we know that s was 4, we just said s was 4. See, s is 4. S was 4. And the whole length, remember, was 50. So 50 minus 4 is the 46 that's left over. So we have the two sides of that triangle. We're looking for the shadow length, w. We know that this little section here, the ball was dropped 30 feet away. So to find the full length of the bottom of the triangle, that's going to be right here, w plus 30. And we have enough to get started. So we're going to say the full length, w plus 30, over w is equal to the full length and the short part of the triangle right here, 50 over 46. When we cross multiply, you end up with, when multiplying 46 times w and times 30, you end up with this value here. And 50 times w ends up with 50w right here. We then proceed to solve for w. So I move the 46 over. That leaves me with a 4. Divide the 4, and w has to be 346 feet. Yeah, that's a feet value. Then we can plug this value right here. Our next problem, going to the back of the problem right here, is our dsdt. We also don't have a dsdt. We don't have a dsdt. So if you check this section right here, we know that s is equal to 16t squared. So I'm trying to get dsdt. So I'm going to take the derivative of both sides in respect to dt. Or in this case, I just took it on ds on one side, dt on the other. Both ways are 100% fine, because on the right side, dt would have divided by dt to become 1. So the derivative here of s is ds dt. If you wanted to write, or I wrote just ds, the derivative of 16t squared is 16 times 2t dt. I got rid of the dt, becoming ds dt, and 16 times 2 is 32. We have a t value. This, as we went back to the problem, says happens 2 seconds later. 2 seconds later. So I plug that in here. 32 times 1/2 is 16 feet squared. And then we, like I drew here, we plug it back in. Plug it back in into my dsdt. Now we have pretty much everything we need. I proceed to say negative 30 minus 345 is negative 375. I multiply that by 16 here, gives me negative 6,000, and we're going to go ahead and move over R4. 1000 divided by 4 is 1500. And that's going to be not inches. This is the part where I messed up. Feet, because our units have been in feet per second, which is kind of fast. Okay. All right. Hopefully that's helpful.